So for our second one, we actually have a medical modeling example that I wanted to show. So if we jump to the next slide here, um, with this one, I believe a white light scanner was used, and probably on a smaller scale along the lines of one of these, like this one here. A smaller sized object. And you see the scan isn't even complete, but we were able to reverse engineer the whole thing. But I believe it was a white light or blue light scanner that was used on this one. So if we jump over, it was a medical object here, and you see it's this type of brace. It's a really neat application, and it was actually quite quick to reverse engineer, and it was only 2 hours to do. So if I go ahead and jump over to the Design X, we'll get started here. So here we have the medical part that we talked about. And for those of you that don't know what this is a brace that you would screw into bones, right, and screw them back together. So this is made to like fit a custom shape here. And here's the scan. And we'll turn off the solid there. This is the scan that they've captured it with. And we'll rotate it around. So we can go ahead and just roll back and take a gander and see how they went about doing this. But this is really neat just to kind of show the fact that we went ahead and modeled this medical part, using it for medical applications. So we'll go ahead and you see there that we were able to just turn on the surfaces there and rotate that around, and we'll come over to that. You see there that we just went ahead and rotated that about so that is a surface. And because it says surface torus, it means that they probably used a primitive here. So if you come over and you see here that it says torus, you can select a boundary or a region of a mesh and say you have to fit a torus to that, and it will fit it automatically to it. So you can select that, and if you turn on regions and we turn off that surface, I can click on that torus, and you see as long as the geometry type is set to torus here, and which it usually, if it is torus and if that shape is actually a torus and the scan data is accurate, it should recognize it properly. And then you come over here, select torus, select that region, you hit next, and you see here you can adjust. I did surface primitive, but I can also reduce this down to 5%. And you see here it's creating the entire torus right now. But the idea here is that it can extract it for you automatically. So just cancel out of that. I'm not going to actually extract it. So there we go. Extracted the torus. And then we go into an offset surface. We'll turn our surfaces back on and toggle that other surface. We went ahead, it's a constant thickness, and it validated that it is by offsetting it. And you see here that you can double click on it and see a 0.1 offset value there. And you see they also went ahead and did a silhouetted mesh sketch as well. So if we come over here and let's just flippy flip around there, turn this off, turn that off, and you see they went ahead, here's the mesh, they went ahead and drew it all out and created the geometry that we're going to use to create a solid from it. So then they went ahead and did a solid extrude, and cut the top and bottom. So we got the overall shape is kind of nailed down here. And then they created some more regions here. So we'll just roll forward and see what they did there. Yep. And the reason they have it here and it says sphere is this is the same thing as what we just talked about. Is they went ahead and extracted a sphere using primitives over here. You can tell by the naming of the revolve. So they went ahead and cut that first one away, cut the second one away, and then they're going to do the same thing here. They're going to fit both of them and then cut them both away. And depending on the part, you may be able to pattern this in a certain way, but you'll notice, look at, they're very, very different here for specific reasons, probably. So you see they went ahead and fit those. And then they did mirror it across there. So they went ahead and cut it and mirrored the entire part. And then they went ahead and you can see here they're adding this little pocket here. So we'll turn the regions off so we can see it better. And then there were some more holes to cut in it. Let's see what that surface offset was. Offset that down. Oh, yeah, so they countersunk all of these by doing an offset surface down and then using this sketch here and drawing those from that perspective and cutting that up to surface. And then we'll go ahead and turn it off, and there you go. You created this beautiful part that's going to screw bones back together, I think. I'm not positive, but it's really neat application there.